Welcome to this video on applications of percent. Let's begin. Each of the following word problems can be set up as a proportion. Remember, a proportion looks like this. A over B is equal to C over D. Of course, neither B nor D are allowed to be equal to 0 because we can't divide by 0. Each of these word problems contains a part-to-whole relationship. Before we begin these problems, let's examine some common part-to-whole relationships. So the first part-to-whole relationship we see is tax. So if you're talking about, for example, sales tax, the amount of tax that you have to pay is based on the selling price. So your part-to-whole relationship is the amount of tax that you pay divided by the total value of the thing that you're purchasing. What about tip? So it is customary in some countries, such as the United States, to tip restaurant servers, hairdressers, and other service industry workers. The tip is proportional to the cost of the service. So the amount of tip that you pay divided by the cost of whatever service you're buying, or if it's a restaurant, the amount of money you're paying for your meal would be, that is the part-to-whole relationship. So the amount of tip divided by the total cost. Then there's also sales commission. So some jobs, sales jobs, have the amount that you earn is proportional to the amount that you sell. So in other words, if you went a whole month and let's say you're a real estate agent and you don't sell anything, right, then you're not going to make any commission. So the commission is the fee that's being paid to an agent or salesperson, again, based on the amount that you sell. So the idea is that the more you sell, the more you make. Then there's also discounts and sales. So you've probably gone to the store before when you're buying maybe groceries or clothes, whatever, and you see an item is discounted. So the discount is the difference between the original price and the sale price, okay? And that's the monetary discount, okay? The sale price is the original price minus the amount that is discounted. And then there's also the rate of discount. So maybe you're buying a nice shirt and it says that it's 20% off, right? So that would be your discount rate. So again, the part-to-whole relationship is the discount divided by the original price. Last but not least, this is probably the most complex example, is a percent increase or decrease. So one example of this would be if you get a raise, right? So if you, let's say you get a 5% raise, to calculate how much money that is, right, you would have 5 over 100, and then the way we do percent increase or decrease is the new value minus the old value divided by the old value. Also, some words that are associated with percent increases and decreases are appreciation. So if something increases in value over time, it's said to appreciate. Depreciation is if something decreases in value over time, it's said to depreciate. So let's go ahead and jump into our first example. So in all of these examples, we're still going to set up a relationship that says percent over 100 is equal to part-to-whole. So we're still establishing, we're writing down proportion and solving it. So let's read the first example. It says, Julia is buying a shirt for $12. So remember, one strategy in word problems is to circle the important information. So let's circle $12. Okay, it says, how much tax will she pay if the sales tax rate is 6%? Okay. So 6%, remember from the previous video we learned that as soon as I see a percent, I can rewrite it as a fraction, because remember, percent means out of 100. So we have 6 out of 100 equals something over something. Okay, so now the next thing we have to do is we have to figure out is what kind of part-to-whole relationship we have. Okay, so we're talking about tax, so if we go back here, right, we're looking at a tax relationship. So the relationship is that the amount of tax I pay is proportional to the total value of the item. So in this problem, is $12 the amount of tax that Julia is paying, or is it the value of the item? Well, it says that she's buying a shirt for $12. So $12 is the whole, it's the total amount that she's paying for the shirt. So then, right, the thing that we're trying to find is the amount of tax that she will pay. Therefore, the x, or the unknown quantity, is the part, right, the amount of money she has to pay on a $12 shirt. So we have 6 over 100 is equal to x over 12. So now, just as we did in the previous video, we can just cross multiply and solve. So we're going to have 6 times 12, equals 100x. So we have 72 is equal to 100x. divide both sides by 100, and we find out that she has to pay 72 cents in tax on a $12 shirt. All right, let's do another example. Number 2 says the restaurant bill was $68.75. So again, employing the strategy of circling important information, let's circle $68.75. Okay. It says Ingrid paid the bill and left a tip of $11 for the waiter. What percent of the bill was the tip that Ingrid left? So remember, when we see the words what percent, we know that the mystery value is the percent. So what percent? We're going to rewrite that as x divided by 100 is equal to something over something. So now we have to figure out which of those two numbers that I circled in red, which of them is the part and which of them is the whole. And again, if we go back here, okay, we can see that we have a tip relationship. That's what this problem is talking about. So the part to a whole relationship is the amount of money that I left as a tip divided by the cost of the product or service. So if we go back here, right, the tip is the $11, right? So that's going to be my part, okay? And then the bill, right, the total cost of the meal is $68.75. So again, if I look at this relationship, the tip is the part, the cost is the whole, okay? So this is going to be my part, right? This is going to be my whole, okay? So $11 divided by 68.75. Okay, so now what we can do is we can, again, cross multiply and solve. So we have 68.75x is equal to 1100. Then we're going to divide both sides by 68.75. And when we do that, we get 16. However, remember, this is a little bit of a tricky problem, right? Because we're not asked what value, but what percent. So our answer isn't complete until we put a percent sign after 16, okay? So the question is, what percent of the bill was the tip, right? The answer is her tip was a 16% tip, okay? So not $16, right? Because she left $11, not $16, it's 16%. All right, let's keep going. So this one says, Sealy is a salesman and earns a commission of 2% on all of his sales. He received a commission check for $7,000 in the month of March. Okay, what was Sealy's sales amount in March? That's what we want to know. Okay, so again, my strategy, as soon as I see a percent, right, I'm going to take that percent and I'm going to rewrite it as, a fraction. Okay, so we have 2 over 100, right? 2% means 2 out of 100. Okay, and then, right, we have two values. We have the $7,000, okay, and then we have the sales amount, which of course is going to be X. So the million-dollar question is, right, which of these is the part, which one of these is the whole? So if we go back to this, right, we're looking at sales commission, okay? So the part is the commission, the whole is the total sales. So if we want, we can make ourselves a note here, right? So the commission is going to be the part, the total sales is the whole. Okay, so let's reread this problem. It says he received a commission check of $7,000. So is the commission the part or the whole? Well, the commission is the part, right? His commission is only a very small percentage, 2% in this case, of the amount of sales that he sold, that he made. So we have 7,000 over X, right? So again, we can see that this is the sales amount. The sales amount is the whole, or the denominator. So now we have our proportion. We can go ahead and cross multiply and solve. So we have 2x is equal to 700,000. We divide both sides by 2, and we find out that his total sales was $350,000. All right, let's do another problem. So in this one, it says, Bridget registered to take a class at the local community college. Due to a program with her employer, she only had to pay 60% of the tuition. If a 3-credit class costs $1,101, how much did Bridget have to pay? So again, as soon as I see my percent, I'm going to rewrite the percent as 60 over 100. So now I have 60 over 100 is equal to something over something. So what are we talking about here? What relationship do we have? Well, we have a discount or sales relationship. So you have the discount divided by the original price. So let's think about this. So she only has to pay 60% of the tuition, right? So in this case, we're going to have 60 over 100, right, is going to be the amount she pays, right? She only pays 60%, right, divided by the original or the non-discounted price. Okay, so let's look at this 1101. So we really only have two options at this point, right? Either 1101 is going to go upstairs, or 1101 is going to go downstairs in our denominator. So the question is 1101, is that the part is the amount that she's paying, or is it the amount of the original price of the course, right? Well, there's two ways you can know. It says that it costs 1101, right? So that's going to be the original price. Also, it says how much did Bridget have to pay, right? In other words, the thing that we're looking for is the x, right? The mystery number is how much she had to pay. We want to know what is 60% of 1101. Okay, so again, 1101 is the whole. It's the undiscounted amount of the course, right? X is the amount that she paid. Okay, so again, we can cross multiply and solve. So we have 100x is equal to 1101 times 60. So then we can just divide both sides by 100, and we find out that x is equal to $660.60. So that's the amount that she pays. Okay, number 5. Number 5 says Angela sells cars for a living. In 1 week, she sold $37,500 worth of cars and earned a commission of $1,875. And it says, what is her commission rate? That's what we're trying to find. So notice in all the previous problems, we were given a percent, right? And that was the first thing that we did. In all of our previous problems, we wrote down a percent. However, in this problem, we're not given any percent, right? What are we given? We're just given two numbers. So if we go back to this table here, right, we can see that we're talking about what? We're talking about commission. So this is the relationship that we're looking for. Commission divided by total sales. So if we want to, we can take a minute and remind ourselves that this is what we're looking at. Okay, so which of these two numbers is the commission and which one is the total sales? Well, it says she earned a commission of $1,875. So the commission is $1,875. Right, her total sales, it says she sold $37,500 worth of cars. So what's the other part? We're missing our other fraction. Well, the key here is that we're looking for a rate. In other words, a percent. So our mystery is basically what percent, right? What is her rate of commission? Does she get a 5% commission, an 8% commission? We don't know, right? So that's what we have to find out. So now we have our proportion. So just as always, we can cross multiply and solve. Oops, let me change to my chalk. So we have 1875 times 100 is equal to 37,500x. And then we're going to divide both sides by 37,500. Okay, and you get x equals 5. However, right, 5 isn't my final answer because her commission isn't $5, right? It's 5 what? It's 5%. So she makes 5% of whatever she sells. She earns 5% of that. Okay, let's keep going. So number 6 says Glynis earns $43,500 a year. Due to a promotion, she will get a 5% raise next year. What is the dollar amount of her raise, and what will her salary be next year? So this is a two-part question. So we're talking about raises. If you look at these relationships, you don't exactly have, right, anything that talks about raises specifically. But we do have a relationship that has to do with percent increase and decrease. So let's go back here and see if we can break this down and figure this out. So the first thing I'm looking at is that I see that she has a 5% raise. So I know that it's going to be 5 over 100 is equal to something over something, right? So what is that? Well, we know that the 5%, right, is going to be, this is the amount that she gets, right, the extra money that she gets, divided by her old salary. Okay, so what we're trying to find, right, we want to find the dollar amount of her raise. That's the mystery number, so that's going to be X, right? But we know her old salary. We know her old salary is $43,500. Okay, so we're going to have 5 divided by 100 is equal to X over 43,500. So now that we have that, we can cross multiply. So we have 5 times 43,500 is equal to 100x, and we're going to divide both sides by 100. Okay, so the dollar amount of her raise is $2,175. So in all the previous problems, right, we would normally be done. However, right, there's a second part to this question. It says, what will her salary be next year? Well, isn't her new salary going to be equal to her old salary, right, plus the dollar amount of her raise? So she made $43,500 this year. She's going to make $2,170 extra next year. So her new salary is going to be $45,675. All right, let's do a few more problems. This problem says Gretchen's favorite store is having a 20% off sale. So Gretchen decides to buy an outfit she likes. Then it says that the regular price of the outfit is $82, and how much will it cost on sale? Okay, so this one, right, if we go back to our table, we're talking about discounts. Okay, so we have a part-to-whole relationship, so we have the amount of the discount divided by the original price. Okay, but what are they asking for? Are they asking for the discount, or are they asking for the sale price? Well, they're asking for the sale price. So let's just go ahead and set it up like we normally would, okay, and then see what happens. So normally, right, we would take this 20%, right, that's the first thing we do, and we rewrite it as a fraction. So we would have 20 over 100 is equal to something over something, right? So remember, if I just steal that fraction, right, steal that relationship, it's the discounts, right, divided by the regular price. Okay, and we don't know the discount, that's what we're trying to find, but we do know that the regular price, or the original price, is $82. Okay, so now we have a proportion, and we can again cross multiply and solve. So we have 20 times 82 is equal to 100x, and then we divide both sides by 100, and when we do that we get $16.40. So let's just pause here for a second, okay? So if I told you that an outfit costs $82, right, but I only paid $16.40 for it, does that sound like 20% off sale? No, absolutely not. That doesn't make sense. Okay, so what we found is not the sale price. What we found is the discount, okay? This is the amount of money I'm saving. So if I go back to this relationship here, I really need to add, right, another relationship here, and that is the fact that the sale price, right, is the original price minus the discount. Okay, so I have to do a little bit of extra work here. Okay, so let's write that out. So my sale price is equal to my regular price, or original price, however you want to say that, minus my discount. Okay, so my original price was $82. Okay, the amount of money that I'm saving, or the amount of money that I'm not paying, is $16.40. So I have to subtract those to find out the sale price. And when I do that, I get $65.60. So that is the sale price. So be careful on these problems, right? Think about what it's asking you. If it just asks you for the amount of money you're saving, right, then the $16.40 would be your final answer. That is your discount, or the amount of money you're not spending. But if it asks you for the sale price, you have to be a little bit careful and do this extra step. and take the original price, subtract off the discount to find your sale price. All right, last question. It says little Timmy has been sick all week. On Monday, his fever was 102.4 degrees. By Friday, it had decreased 2.7%. What was his temperature on Friday? Round your answer to the nearest tenth. So if we go back to this relationship chart, right, we're actually looking at a percent increase or decrease. Okay, so remember our relationship is the new value minus the old value divided by the old value. Okay, so let's write that down. So we have the new value minus the old value divided by the old value. Okay, that is our part to whole relationship that we're thinking about. Okay, so let's circle the pieces of information we're given. We're given his original temperature, right? So this is going to be my old value. Okay, and then we're also given the percent decrease, which is 2.7%. So we have 2.7 divided by 100. Okay, so now what are we going to do? Well, we can replace the old value, right? We can replace it with 102.4 degrees. Okay, now you might be thinking, right, well, I could also put it here. I absolutely can. I can do 102.4 degrees. And if you wanted to, right, you could absolutely cross multiply and solve this if you want to. However, okay, I'm going to make it a little bit simpler, a little bit easier for us, because what we usually do, right, is we usually put x over something, right, equals, this is how our proportions usually look. Okay, so again, this is the new value minus the old value divided by the old value. Okay, so let's just replace this whole thing. Let's just replace it with x. Okay, solve for x, and then we'll take another step. Okay, so again, we're going to cross multiply and solve. So we have 2.7 times 102.4 is equal to 100x. Then we divide both sides by 100. So we get x equals, so we have x equals 2.7648. It says, so let's not round it yet. Okay, let's leave it right there. Okay, so what is x? Remember, we replaced this whole numerator, the new value minus the old value, we replaced it with x. Okay, so what does that mean? That means that we have the new value, I'm going to just write it as n. New value minus the old value is equal to 2.7648. But we know, right, we know the old value. What was his original temperature? Well, his original temperature was 102.4 degrees. So the new minus the old is equal to 2.7648. So to solve for his new temperature, okay, we can just add 102.4. However, we have a little bit of a tricky problem here, right? Because this looks like his temperature is increasing, isn't it? Right? But what did it do? It actually decreased, right? It decreased by 2.7%. So this number, right, we actually need to make it negative because it's actually being subtracted from his original temperature. So we have 102.4 minus 2.7648. And when we do that, we get 99.63 degrees Fahrenheit. So this is his new temperature.